Welcome back, everybody. Today in this video, we're going to show how to do easy modeling of a simple system. System we're going to model is the simple system shown in Appendix S of the B31.3 code, which you see here. It consists of 6 elements, 2 bends, 2 anchors, 1 intermediate restraint, a couple of extra nodes. It's 16-inch standard pipe, A106 grade B. As far as operating system conditions are concerned, it's got 2 temperatures, 500 degrees and 30 degrees with an ambient of 70. The 500 degrees has a 500 psi pressure associated with it, and 30 degrees has 0 pressure. And I guess the number of cycles, 7,000 cycles. Anyway, the information's here. It's in the back of in Appendix S of B31.3. So let's go ahead and start to model. To start, if you looked at the second video, which was how to set up, you should go into your configuration and make sure that everything's set the way you want. Deformed shape display scale at 5, node increment 10, that looks good. Default units, we want to be set to English 1 for this situation. We want to have 2 different intermediate bend nodes defaulting at 0 degrees and at the midpoint. So that looks good. We, oh yes, and we want to default to B31.3 code. And let me see if we have a 16-inch pipe in here. We have a 16-inch pipe. If you don't have one, go to your catalog, pipe sizes, go look at your steel shapes, imperial. Go look at your 16 standard and add that item to the library if you don't have it. That's what we're going to need. And as far as materials concerned, we do believe have A106B. So we're ready to go now. So let's model a new pipe, new model. We want to give it a name, new. We can call it Appendix S, I'm sorry. Click here, mine exists. I'll overwrite it. Yours may not. And we're going to model this a simple way. We're simply going to type data in here. There's much more easy and much slicker ways to model in CloudCalc, which we'll look at in future videos. It's virtually all graphic in nature, but here this is going to be simple typing in things as we go along. So the first element goes from 10 to 15, so we want to change this default 2 node. It is 20 feet long, so we can say 20-0. And as we move forward, you see it draws a skeleton here, basically showing you the way that this element or this piping section is going to go. But nothing, because we haven't said page down or left this screen yet, nothing has processed. So the pipe size is going to be a 16-inch standard. The material is going to be A106B. The insulation happens to be 5 inches of insulation, calcium silicate, which is 11 pounds per cubic feet. The corrosion is going to be 0.063 inches. Put in. We don't have a bend, we don't have a valve, we don't have an expansion joint reducer. We do have a restraint that we can add here, or we can add it from this input restraints. We have 2 options here, or 3 options if we consider the graphic modeling that we're not going to do yet. So we say restraints, we want to add a restraint. We can put on the from or the to node here, the anchor or any of these other different types of restraints. We can give it stiffnesses, gaps, frictions, etc. Go ahead and save that. Operating conditions, temperatures. We've got a temperature of 500 degrees. We'll call that temperature 1, save that. And then we want temperature 2 case, which is going to be 30 degrees. And we've got a number of options on the temperature case. Call that temperature 2. And by the way, just to make sure that we are using an ambient of 70, which was required, we can look in the job parameters, and we see that our ambient temperature here, yes, is 70 degrees. Piping code's 31.3, that came from our defaults from the config, etc. Okay, pressure. We have a pressure case of 500 psi, and pressure 1 and pressure 2 is 0, so we can either leave that, specifically model a pressure 2 of 0, or we could just leave it blank and not included in the load cases later. The fluid contents, I believe we have one fluid, which is specific gravity of 1, so water. We've got a number of fluid cases, which we can vary, but if we just have this one case, we'll leave that in. Uniform loads, concentrated loads, displacements we don't have. And now if we page down, we see that it did the processing, and we have our pipe. We want to verify that our load cases took. We could look at our temperature case, which is 500 for temperature 1, is 30 degrees for temperature 2, etc. 500 psi for temperature for pressure 1, 0 for pressure 2, etc. So it looks good, or else we could check those load cases, piping loads, for example, in here. And we see that we have specific gravity of 1 from element 10 to 15. So once we move on to the next element, operating conditions, pipe sizes, materials, insulation parameters, corrosion carries forward, so we don't have to re-enter that here. Let me reset this to none. Okay. So we don't have to retype all that stuff. So now we're going element node 15 to 20, and 15 to 20 is going to be 20 feet as well, so it's 20-0. There's a restraint at the 2 node, so we want to say that's at the 2 node, and there's going to be a Y direction restraint. We could add some other information here if we want to do, but we don't need to. So now we hit page down, that thing processes, etc., and we're beginning to model our system. Fairly easy so far. Next element, 20 to 30, is going to go 10 feet in the X direction as well. Down at that end, we have a bend. If we click that, it opens up this further information on the bend. If you want to see it or not see it, hide it, we can click this link here. Defaults to a long radius bend. You can change that if you want. It fills in those 2 intermediate node points, the way we had in configuration: miter cuts, wall thickness, bend, additional flanges, etc. We don't have any of that. So we continue. Next, we're going to move up in the Y direction, 20-0, 20-foot 0. Again, we have a bend there. See the skeleton moving up, so it confirms you're going in the right direction. Again, defaults to long radius bend, 2 intermediate node points, as we expect, and we hit page down, and it processes. Now we can close this. 40 to 45, so we want to change that 2 node. It's going in the X direction. It's going to go 15 feet, so we go 15-0. There's nothing going on here. So we close page down. It processes it, fills it out. And finally, we go 45 to 50. And that's 15 feet in the X direction as well. And there's a restraint on the far end. So it's on the 2 node. It's an anchor. And we can say save and page down. And we're now completely modeled. So what sort of things can we do to this? We can verify, we can look at different views. So there's X, Z, Y, 3-dimensional. So the shape looks right. We can verify that we're in the right place by checking with our running nodal coordinates. So node 50 should be at 80 feet in the X direction, 20 feet in the Y direction, and 0 feet in the Z direction. So that's correct. And we can verify that our load cases are all correct, so that the temperature carried through. So it's all the same color, 500 degrees. It's all the same color, 30 degrees. It's all the same color, 500 psi. It's all the same color, 0 psi. And it's all the same color, etc. 1 specific gravity, 1 SG water. Or again, we could have checked those loads in these tables here and see which elements have what temperatures, pressures, fluids, etc. Graphically, it looks like the restraints are there. If you want to confirm that, you can go to this table, an anchor at 10 and 50, an anchor at 20, etc. So that looks good. So now that we've got this thing modeled, we want to go and run it, which means generate static load cases. Go to Input, Static Load Cases. Initially, there's none. We can add them by clicking here, and we can actually say, let's include self-weight with a factor. Let's include fluid with a factor. And self-weight includes the pipe and the insulation, things like that. Fluid with a factor. Or, if we wish, we can say initialize load cases. In that case, CloudCalc will look at what individual load components do you have, what code do you have springs, etc. You need to do a restrained weight and free thermal for spring design. If not, we can click initialize, and here it came up with 2 operating cases. One includes self-weight, fluid 1, pressure 1, temperature 1. Second one is self-weight, fluid 1, pressure 2, temperature 2. Then we've got 2 sustained cases, which is going to be self-weight, fluid 1, pressure 1, self-weight, fluid 1, pressure 2. And as you see, we have the stress types called out. We tell how we want to model our hangers and things like that. And then we have our combination cases. So we have combination 1, which consists of the difference between load case 1 and 3. It's an expansion case, combined algebraically. Second combination is the difference between load case 2 and load case 3. It's expansion, combined algebraically. And we may want to check and see what happens when we go from the hot 70 degrees to the 30 degrees. So we might want to add a combination case. So we can say load case 1, factor of 1, load case 2, factor of -1. And we want to make that algebraic, and we want to make that expansion. So we can save this case. So now we've got our load cases built. If we do analysis, it'll go through a error checker, make sure that you didn't do anything crazy in here, and then it'll give us our results. Displacements, we've got 7 different load cases. Displacements, element forces, element stresses, code compliance, color coded. Green is pass, red is fail, blue is pass, but within 85% of the, within 15% of the allowable. And we can step through our various load cases here. So this was operating case 1, operating case 2, sustained case. If you want to search or sort, this is all sortable. We can search and say, let's find case 40 to 45, or element 40 to 45, it's here. Okay, we can go to expansion, the next sustained case, expansion case, etc. So it looks like everything passes. Once we've run the analysis, we want to get the results. We can hit print here, and we'll get ourselves a nice PDF report, which has a little picture, whatever was on the graphics at the moment, basically an input echo, the load cases, and your displacement element forces, all of your reports, followed by table of contents. And here you see you got a lot of reports. We got 40 pages here. You may not always want that. In that case, you can limit what goes into your output viewing. You do that by selecting elements. You can either say E or select by element, or E, the same thing, hotkey. And we could say I'm interested in this one and maybe this one with control click. And then we say, if we say selected only, it will only show those elements. It will only show those displacements. It will only show restraints on those. And likewise, if we go to do our printout, then our information will be much more limited. Still maybe the 40 pages, but now a lot less info on each page. So we can do the report on the screen. We can do the report on print. Oh, and again, if we select something else here now, just click this selected only link, and it'll change the report to reflect that new selection set. Also, we can do output to Excel, and that as well handles the selection selection only set. So if we look at our Excel output, it has all of these various load cases, reports, various load cases, everything. So that way you can do some sort of post-processing if you wish. And anyway, so that was simple output, simple analysis, running this model. And next video, we're going to do something a little more complicated and a little more fun, and a little, well, it's a little more complicated, but more powerful, more fun and easy. We're going to do entering a model via graphic input. So anyway, thank you for attention, for hanging on here, and hope to see you next time. Thanks.